Today we're going to go back onto a 1981 set, and it's a Colt 355 which we haven't covered. It's June 82 this one, it's a late version. I've done these before but not on video, so we've not done any of the Colt ones. The only three ever for the UK market was the Colt 295, which is the Maxon 4E, a Colt 295A, which has a difference in that on the 295 you have, on the single switch on the front, on that it is high or low RF gain, and on the 295A, in line with what MPT 1320 required, it has high-low power instead. So there's two variants. And then the later 355, which is this one, which I think is going to be a Maxon 20, but in a metal case. Now this has come with the power lead stub. And by that I mean it's got the moulding intact, and it's got a power lead as far as there, but no fuse, and it's too short. So I'll go and sort that out. We'll put a fuse holder to it and lengthen that. We can do these. We've got the tools. It's quite time consuming to make. We can do them, but they're horrendously expensive. I mean, something like $5.99 a piece by the time you put a fuse holder and a fuse in them. So it's nice when they come with a bit of a tail. And the other thing we need to do is to make up a microphone, and on this it's a 5-pin DIN, and we use the high quality metal plugs because those nasty 20p plastic ones are awful. So we'll get to standard mic. I'll put that to it. But what I'll also do is we'll open this setup, take that out. This will have come in a batch of stuff because I've covered I've done our sample. It says on my computer that I have. I bought one off eBay. I did it, and that's before I started doing these videos. So this has had quite heavy use, because you can see by the wear on the front panel. Around the channel selector, you've got wear. So somebody's obviously well loved it. So that's the bottom, and you have to unsolder the speaker. Now, as I said before, polarity doesn't matter on speakers, but let's just look at what they've done. I would have thought yellow was going to be positive, and the way this is, you see, I can't even read which is positive and which is negative on the speaker. So the way you'd tell is if you put something like a 9-volt battery for a moment across the speaker terminals, it's going to move the cone outwards or inwards, and that's how you can work out the polarity. But it doesn't make any difference to sound unless it's stereo. And then you have a phasing problem, and you end up with a hole in the middle of your experience. So there you go. Bit smaller speaker than some sets, but it's a bit smaller set, but it seems to be better than the current offerings. So I dug out the alignment details for the Maxon 21E because I'm sure that it's the same kind of arrangement. Anyway, we'll make up a chart and we'll go through it. I'm just wondering what they use as the fairy light driver. Shall we say fairy light? That's a good word. It's had the audio IC changed on this. That surprises me because I very rarely have to change audio ICs. I don't know what people do to them, except short the extension speaker socket out. The high-low power's on the back, and you've got a useless channel 9 switch on the front. Well, that looks absolutely pristine and untouched, so I'm sure that's going to work great. So I'll go behind the scenes and I'll do the microphone plug, which is 5-pin DIN. It's on our chart. We're using this one at the moment, so it's connection number what? it says 9. Yeah, I can believe that, because same as Maxon. So, audio, screen, transmit, receive, and blank. Right, so we've done some of that. So I've looked at the instructions for alignment. I can see only a few of the... That's the test set making a noise. That appears to be the S meter. That appears to be the squelch. That's going to be the detector. What else have we got? That's going to be deviation. Sorry, that's transmit frequency, TC1. That's deviation. That's going to be RF meter. Don't know what RV104 is. I haven't worked that one out. Perhaps it's the low power adjustment if it has one. So that's a start. Now, clearly that's going to be transmit, and that's going to be transmit, and that's going to be transmit. It might be the 54 meg trap, which we don't want to adjust. So, yeah, it's unfortunate when the board's not got any. The parts are covering the writing, so we can't see what they are anyway. Could have done with a layout, but I haven't got one. So we'll connect that up to the test instrument. And done the microphone with a 5-pin high quality plug. And somewhere I did that power lead. Oh yes, there it is. Waiting for a fuse to go in it. And the fuses are there. Okay, so we've joined it with a soldered splice there and put some not self-magnet, what am I on about? Heat shrink tubing round that, so that's the original one. Got a bit longer, that can go into our power supply, and hopefully Bob's your uncle. So how well is this 38-year-old radio going to work? Because it's clearly worked very well for somebody in the past. They wouldn't have put that much wear on it. So we'll switch it on, we'll switch the power supply on, we'll switch it on, got channel 9, and we'll pop that up to channel 20. I'll just temporarily put the test instrument in. We're on normal power setting, and we can hear the FM hiss. So let's have a look. Switch picture in picture on, and check the camera is actually showing the meter, which it is. So we're at more than full scale deflection on the 3 watt range, and so it's doing about 3.3 watts. So we'll go straight for whichever that transformer is. And that was at peak. We need to melt the wax in that one. And use a different tool. We'll just check that, but I might have to just check that with the spectrum analyzer. Could be the 54 meg trap. It's peaked. That's peaked. These are interactive, as I've always said. So we'll just check that. I don't know whether these are transmit or receive, so we'll just do a quick adjust. It doesn't matter. Transmit. So that probably is as well. Yeah. So about 3.7 watts. So I'll just make a note with the highlighter pen. That's going to be VCO, we're not touching that. And there, TX. Good. So let's have a look at the meter once again. I've gone through those a few times, and we've got about 3.8 watts. Now, the radio is hot, so when it's cold, it will be doing 4 watts. So we'll call it 3.9. We'll give it the benefit of the doubt. So the next thing I need to do, let's see if it's on frequency. So I'll move the camera across, and we'll just look at that. Should be 27.79125. 79090, because it's dropped with age, which is what happens. So we'll just pop that back up to frequency if it'll go. It's not out of spec, but we may as well pull it up to where it should be. We'll leave it at that. 25 toggling 26, can't be bad. So I'll move that camera back to there, and at the same time let's see what the fairy lights say. So I'm keying up and it says 3. So I reckon that RF meter is RV103, which is that preset. If I just move that wire out of the way, just there. So I want it to just read 4. There we go. So just read 4. And it does. So that was correct. So I wonder if the unknown control, we'll switch it to low power and see what it's doing. It should be doing 400 milliwatts. It's doing 450 milliwatts. So I wonder if the question mark control down there is. It is. There we go, 400 milliwatts. So it's low power. We've not messed anything up so far. It's what you call an educated guess. So let's look at deviation, which is going to be that one there. So I'll give it a quick whistle test for a start. Whoa, 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 whoa. It's 5 kilohertz. Somebody's had this screwdriver in that. Yeah, I'm really loud to Fidelity 1000, but I'm distorted to anything else. Wow. Right. Just transmit on 2 channels at once. Walla. Walla. Just a little fraction. I'm getting 2 to 2.1 there. So we'll just take it up that fraction. Walla. Yeah, 2.2, 2.4. It's about where we want to be. It's an absolute maximum. So that's deviation done. So that should be transmitting a treat now, unlike a lot of new sets. So let's look at receive, and we'll go over to receive, and I will set the frequency counter, the signal generator, 27.79125. we'll move the cameras over to the oscilloscope, because on these sets the detector is something that nearly always needs attention. So we're going to put an S9 equivalent signal on, which is 100 microvolts in the UK for a CB, and there we have the sine wave showing, and we want that to be maximum, and that's going to be the detector coil, which is there. I've only had to get a fraction more out of that. So now we'll move the camera onto the synod meter, and let's see where we can weave some magic. So at the moment 0.3 microvolts is that, which is pretty rubbish. So we want about 4 decibels on there to make it easy, and we'll go through the receiver. We've gained a fraction there. Gained nothing there. Nothing there. This is IF, so I just need to do a different type of thing. We'll have it about 12, and I'm looking at the shape of it. We'll go through these again. I'm beginning to think this one is nothing to do with receive, so I'm just going to check that with transmit. Yeah, it's one of the transmit ones. That's today's first error. So I missed one on the diagram. One, two, three, that's it. Well, it's not very good receive, I'll give you that. Not by the sets we've been doing recently, both ancient and modern. So we'll get some readings, see how bad it is. Okay, so So 20 dB synod, that's always subject to the noisy transistors or not noisy transistors. I've told you the story before about the Hitachi cassette deck a friend of mine had. He had no intention of wanting to use Dolby, but he had to use Dolby to mask the fact the transistors in it were dreadfully noisy. Awful. I was telling you about my organ boss yesterday, and how he asked his wife rather rudely for more gravy and said, "More gravy, woman," and she dutifully put more gravy on his plate. Well, when he died, he was 73, which is actually the same age as my late father. When he died, and I didn't bother going to his funeral, it was at a church where the organ was out of action. They had a horrible electronic organ, so he spent 40 years in restoring pipe organs and being a horrible person. Then at his funeral, he had to put up with it being an electronic organ, so there was a bit of comeuppance. Right, for 20 dB, it is 1.7 microvolts. And I'm not bothered about that. This is the next one's the 12 dB, which is the industry standard one. Yeah, we're not getting anything on that scale, so let's have a look what we can get. So, actually, it's 0.75, so it's not that crummy. And then I've been spoilt by some of these sets we've done recently. For 12 dB, it's 0.65 microvolts. So it's quite possible that when you bought this set, it says better than 1 microvolt sensitivity for 10 dB cyanide, and it is better. It's better than 1 microvolt for 12 dB cyanide, but I've been spoilt recently, and so I think this is now pretty crummy, but it isn't. So let's look at squelch sensitivity. So I'll just pop the camera down to the attenuator controls, or the bench. I'll have to get out of my chair to see the monitor. Okay, so we're going to park the signal generator at 0.3 of a microvolt, and we'll just listen for a moment. We can hear the signal generator at 0.3, 0.2, and we're losing it to about 0.15. But we've had some of the recent sets which have been still receiving off the clock there. So, and switch the signal generator off, set the squelch controls the threshold, and switch the signal generator on. Remember, I've parked it at 0.3 of a microvolt. It's actually come in, you see, at 0.3 of a microvolt. So we'll get a fine reading. It's gone off at 0.25 of a microvolt. It's not come back on at 0.3, so it's that was a false reading. It's coming in at 0.5, going off 0.25. So that's fine, it's under 1 microvolt, so it's going to track alright, but let's see where it is at full squelch, because as I've said before, we don't want them to be more than an S9 to open up the squelch, otherwise you've got the danger of it never opening on any signal. So it's not opening it at 100 microvolts, so let's see when it does. It opens about 1 millivolt, so we're talking about plus 20 or something like that. So I just need to adjust the squelch preset, and the squelch preset is there, so that it comes in at S9. Okay, and that's spot on, that's coming in at S9 and it's going out. So we'll do that minimum test once again. So set it, park it back at 0.3 microvolts for what it's worth. Switch the signal generator off. Set threshold, which is there. Switch the signal generator on. Once again, go over to the 1 microvolt scale. So it's going off just under 0.2 of a microvolt, and it's coming on at 0.48. Off at just under 0.2, on at 0.48. So we've got it right at the top and at the bottom. So there's one final thing to do, and that's just check the S meter. Now Maxon are notorious for setting their S meters for 50 microvolts or even 20 microvolts equaling S9 to make the sets look more sensitive than they really are. And sometimes we can't adjust them to how I believe they should be, which is 100 microvolts. So RV102 is the one just there, and that should be the S meter if it's wrong. So I want it to be, it says 3 0, 3, 9 plus 30. So 9 should be the third light. So we'll see if we can back that off a fraction. We can. There we go. There we are. That's set. So all we need to do now is put the lids on and we'll check it out on the aerial for what it's worth. Actually, I think we'll just look at polarity of speakers. I say it doesn't really matter, but and I don't think they even bother at the factory which way round it is, but I'll just show you how you can determine it if you want to be a perfectionist. We've got a 9-volt battery here. It's kicking around on a shelf just outside the workshop. I've no idea whether it works. We'll just start by testing it. So it's seen better days, but it's got 8.8 volts in it. So it might be possible to offer this up to the terminals of the speaker. What we want to see is which way the cone's moving. So that moved inwards. So this is moving outwards. So if that's moving outwards, then that's negative and that's positive. So the one on the right is the positive. So we'll put a little plus there. And then with your multimeter, we need to find which one's connected to earth of the speaker leads. I've got the radio switched off. So we'll put the meter on, stick it in, I'll stick this one in 200 ohms range. Now you'd expect the yellow to be positive and the green to be negative. That's what I would think. So I'm going to connect, we're set for effectively continuity. So put that on the chassis. So I would think it's the green one. No. So the yellow's the negative. Not what I was expecting, you see. So yellow wants to go to negative, irrespective of how it came out. And then if you've got 20 CB radios all chatting at the same time, they'll all be in phase. You know, you just can't see that, but with that 9-volt battery, we could. So that is the speaker. Don't be tempted to use your 12-volt power supply or you'll end up with a very burnt out speaker. So we'll just pop the lid on that. And get the screws which we've carefully put in the Aldi cheesecake jar. Right, switch off the test set, save some electricity, and connect up the aerial. So it's about 12:15 on a Saturday. Well, it's got GH on the back, that's who owns it. So I wonder what his name was. Or was it a lady? Was it Guinevere? One 919, Roger. I'm in 10 dB attenuation. 1919, Roger. So as ever, nobody on, which is absolutely fantastic. Suits me down to the ground, and we'll do an on-the-air test later. So now you've seen the Colt 355 from 1982. Thank you for watching.